Section 10.2, using the fundamental counting principle. The fundamental counting principle. If a k-part task satisfies the uniformity criterion, and the first part can be done n sub 1 ways, the second part can be done n 1 ways, and so on, then the number of ways to complete the task is n times n2 times n3 all the way up to n sub k. Example 1. How many base 10 two-digit numbers are there? If we're talking about a two-digit number, the tens digit cannot be 0. So there are 9 options with 1 through 9. There are 10 ways to select the ones digit. It could either be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So there are 90 base 10 two-digit numbers. Example 2. How many license plates have 3 letters followed by 3 digits? So in this case, we're talking about license plates that have 6 items on them. And license plates can have repeat letters and repeat numbers. So there can be 26 letters in the first spot, 26 letters in the second spot, 26 different letters in the third spot, 10 digits, 10 digits, 10 digits. So with 7 spaces on the license plate, there are 17,576,000 combinations of 3 letters followed by 3 digits. Example 3, find the number of two-digit numbers without repeated digits. The number of ways to select the tens digit, again, we want a two-digit number, so we do not want that first digit to be 0. So it could be 1, 2, 3, 4, 5, 6, 7, 8, or 9. So there are 9 options for the tens digit. The ones digit could be 0, any number 0 through 9, but we don't want it to be the same one as the first one. So instead of 10 digits there, we have 9 digits available to us. 9 times 9 equals 81. The uniformity criterion for multiple part tasks. It is said to be satisfied if the number of choices for any particular part is the same, no matter which choices were selected for previous parts. So in our numbers and letters for the license plates, it did not matter what we picked first. However, if we're electing a president and a secretary, how many ways can Club N elect a president and secretary? If no one can hold more than one office, and the secretary must be a man. Remember that Club N is Alan, Bill, Kathy, David, and Evelyn. We use the letters A, B, C, D, and E. To satisfy the uniformity criterion, we must select the secretary first. There are Alan, Bill, and David are the men. So we can choose 3 people to be the secretary. Once we choose a secretary, we then elect the president. Number of ways to elect the president, we already used 1, so there are 4 options left. 3 times 4 equals 12. Example 5. How many non-repeating odd 3-digit counting numbers are there? We want a 3-digit number. How many odd digits if we have a 3-digit counting number? Think about it. For it to be odd, it has to end in 1, 3, 5, 7, or 9. So there are 5 options for the odd digit. Number of digits not used as the odd digit. We used 1 digit for the odd. We are not using 0 in that first spot, so instead of 10 digits, there are 8 available. And we have the numbers 0 through 9, which gives us 10 digits. We used 1 for the odd one. We used 1 for the first digit. So there are 8 digits left. 8 times 8 times 5 equals 320. How many 4-digit numbers have digits only from 1, 2, and 3? Just 4-digit numbers from the numbers 1, 2, and 3. Number of digits in the first slot could be 3. It could be 1, 2, or 3. Number of digits in the hundreds place, it could be 1, 2, or 3. 3 different digits. Number of digits possible for the tens place, either 1, 2, or 3. 3 again. And the number of digits in the ones column, 1, 2, or 3. 3 times 3 times 3 equals 81. How many 4-digit numbers are odd, less than 2,000, and have digits only from the set 1, 2, and 3? In the 1,000s place, we want a number less than 2,000. So we're not going to use the 2 or 3. We have one option there. Looking in the ones column, we want it to be odd. So we're only going to use the 1 or the 3. So we have 2 options there. In the tens place, we can use all 3 digits. And the 100s place, we can also use all 3 digits. 1 times 3 times 3 times 2 equals 18. How many ways can Arne, Bobbette, Chuck, and Deirdre seat themselves in consecutive seats 1, 2, 3, and 4 so that Arne is beside Bobbette? A is beside B. Decision 1 is how many pairs of seats can A and B occupy? They have to be next to each other. So they could be in these two, or these two. So 3 pairs of seats would work for them. How many ways can A and B be ordered? 2 ways, either AB or BA. Decision 3, how many ways can C and D be ordered? C can be to the left of D, or D can be to the left of C. So 2 different ways. It's going to be 3 times 2 times 2. 3 times 2 times 2 equals 12 different ways they can be seated. Factorials. The quantity n factorial equals n times n minus 1 times n minus 2 multiplying all the way down to times 2 times 1. 0 factorial is defined to be 1. 5 factorial equals 5 times 4 times 3 times 2 times 1. Multiplying those numbers, it equals 120. The number of arrangements of n objects is n factorial. Example, n equals 4. And we're going to find n factorial. In the first slot, we could put 4 things. Second slot, 3 items. Third slot, 2 items. Fourth slot, 1 item. 4 times 3 times 2 times 1 equals 24. Example 10. How many ways can Tricia arrange her 13 students in a single file line? The answer is 13 factorial, which multiplies to 6,227,020,800 different ways. That's section 10.2, the fundamental counting principle.